The observer pattern powers every notification system, every event bus, and every reactive framework you have ever used. If you understand observer, you understand how modern software responds to change. Observer pattern, low-level design, day 6. Here is the problem. You have a user class with a change status method. When the status changes, you need to notify multiple services. So you call email service.send, then SMS service.send, then push service.send, all directly inside the method. Now the product team says add Slack notifications. So you add Slack service.send, then they want in-app notifications, then webhook callbacks. Every new notification channel means modifying the user class. The user class is now tightly coupled to every notification service. It violates open-closed because you are modifying existing code for every new channel. The dependencies go in the wrong direction. A core domain object depends on infrastructure services, and testing is painful because you cannot test user without mocking every notification service. The observer pattern solves this with 3 parts. First, the subject. This is the object whose state changes. In our case, an event bus. It maintains a list of observers and notifies them when something happens. Second, the observer interface. This defines the callback method that all observers must implement. In our case, an onEvent method that receives an event object. Third, concrete observers. Each notification channel is its own struct that implements the observer interface. Email notifier handles email, SMS notifier handles SMS, Slack notifier handles Slack. Each observer is independent. The subject does not know or care which concrete observers are subscribed. It just iterates through its list and calls onEvent on each one. Observers can subscribe and unsubscribe at runtime, making the system completely dynamic. Here is the code in Go. Define the observer interface with an onEvent method that takes an event. Email notifier implements it by sending an email. Slack notifier implements it by posting to Slack. The event bus struct holds a slice of observer interfaces. It has a subscribe method that appends an observer to the list, and a notify method that iterates through all observers and calls onEvent on each one. To use it, create an event bus, subscribe email notifier and Slack notifier, then call notify with an event. Both observers get notified. Adding a new notification channel means creating a new struct that implements observer. 0 changes to event bus, 0 changes to existing observers. Observer pattern is everywhere in production systems. First, event systems. Kafka, RabbitMQ, and Redis PubSub are all built on the observer concept. Producers publish events, consumers subscribe and react. Second, UI frameworks. React state changes trigger component re-renders, Vue reactivity system notifies watchers, Android Live Data updates observers automatically. The entire reactive programming model is observer pattern at its core. Third, webhooks. GitHub webhooks notify your CI/CD when code is pushed. Stripe webhooks notify your backend when a payment succeeds. You register a URL as an observer and the service notifies you on events. Fourth, file watchers. Nodemon watches file changes and restarts your server. Webpack hot module replacement watches source files and triggers rebuilds. The file system is the subject, your tools are the observers. People confuse observer with PubSub and mediator. Here is the difference. Observer versus PubSub. In observer, the subject holds direct references to its observers. The subject knows who it is notifying. In PubSub, there's a message broker in between. The publisher does not know who the subscribers are. The broker handles routing. Observer is better for in-process communication. PubSub is better for distributed systems where components should not know about each other. They complement each other. Use observer locally, PubSub across services. Observer versus mediator. Observer is a one-to-many broadcast. When the subject changes, all observers get notified. Observers are independent of each other. Mediator is many-to-many coordinated communication. Components send messages to a mediator, which routes them to specific other components. The key difference is broadcast versus targeted routing. When to use observer pattern. When state changes need to notify multiple dependents. When the number of dependents is dynamic and changes at runtime. When you want lives coupling between the thing that changes and the things that react. When you're building event-driven architecture. Red flags that scream use observer. Direct method calls to multiple services in sequence, like calling send on email, SMS, and push, one after another. A growing list of service.send calls every time a new channel is added. Circular dependencies between modules. Common interview questions. Design a notification system. Answer with observer interface, event bus subject, and email, SMS, push observers. Design a stock price tracker. Stock exchange is the subject. Dashboard and alert service are observers. Design a chat system. Chat room is the subject. Users are observers that get notified of new messages. The pro tip is to show the tightly coupled version first, then refactor to observer. It demonstrates you understand decoupling and extensibility. 5 things to remember. Observer pattern defines a one-to-many dependency. When the subject changes state, all observers are notified automatically. A growing sequence of direct service calls is a code smell. Refactor to observer. The structure is subject has a list of observer interfaces. Concrete observers implement the interface. Observer is direct references for local communication. PubSub adds a broker for distributed systems. Mediator coordinates targeted routing. And in interviews, always show the tightly coupled version first, then refactor with observer to demonstrate you understand the problem and the solution.